Okay, hello everybody. Welcome to my introduction to my aquaponics system monitor. I'm just going to go through a few points to introduce this project to people and why I'm doing it. So first of all, we're going to start with what is aquaponics, how aquaponics works, and why it's good. So in this, there'll be in the description, there'll be links to each of these topics, so you don't have to go over any topics that you already know about. So we're going to talk why I'm taking this project, why am I doing it, talk about what the application solves, what problems they solve. We're going to have a look at how the system works, how I'm building it. I'm going to show you how to keep up to date with the project if you're interested. And then we're going to talk about some technical information and maybe how people can lend a hand or get aboard. So the links will be in the description for forwarding to any of these topics. So we'll start with what is aquaponics. Okay. So aquaponics is a system where you have fish in a fish tank and you cycle that water through a garden bed and then the water cycles back into the fish tank. It's a closed system where all you have to do is feed the fish and plant out the garden bed. So the plants are grown usually in some type of medium, these expanded clay pellets or small stones. So you have the plants in the garden bed and you have the fish in the fish tank, and here's another example. Also, you can grow with the plants just in the water, so you can cycle the water through a heap of pipes and then back into the fish tank. So this is very good for using space if you have a small space and you want to grow a lot of food. And here's another example of the fish tank, and then of the fish tanks here, and the water cycles through all this. Very, very, very nice. So there's other ways that you can grow it, which you can have them inside. You could have goldfish and you could have a light for inside, and you could grow all the herbs for your kitchen in a small system like this. Here's another example with a fighting fish, and that's basil, growing basil on it. Here's an example. This is the system that I had. I had my fish tank in a square IBC container, and I have here basil, very good basil, lemongrass, chives and thyme, and I grew a lot of chili. I made my own chili sauce from this setup. I also grew the basil and made my own pesto, and you can make use of the space very, very well. There's a lot growing in a small area. Very nice healthy vegetables. And that's the fish. That's a barramundi fish. It's a warm water fish from Australia. I did have an experiment with my own system inside where I had this here. So this one actually didn't work too good because this type of barramundi fish is a very, very aggressive species. So you had one of these bullying the other, and it wasn't a good choice for fish because they need a lot more space, these fish, or else they pick on each other. And it also needed a light inside. Even though it's very sunny in Australia, this would have grown much better with a light. So okay. So now, how does it work, and the nitrogen cycle? So quite simply, you have fish and you're feeding the fish, and the fish are producing waste. So the leftover pellets that you're throwing in for the fish, or the fish's waste, goes into the tank, and you have microbes, bacteria that grow in the water, and that grows in the garden bed. And this process here produces nitrogen, and this turns that nitrogen, that's ammonia, and turns it into nitrogen, which the plants use, and then that cleans it back for the fish. So it's a very natural very natural process. So we'll have a look at some of the reasons why, the benefits of aquaponics. We'll go through this quite quickly. So aquaponics has to be organic. You can't put any chemicals on your plants to get rid of any bugs or any pests. So it has to be 100% organic. Okay, so talking about this particular farm, these people, they grow 6 times more vegetables per square foot than traditional farming. So you can get a lot in a small area, which is good for urban environments. It's good for your backyard. If you don't have a large backyard, then you can get a lot of produce. So aquaponics uses 90% less water than traditional farming, which is really good for countries like Australia, United States, Israel. Where this is popular, it's usually something to do with the water. Also, you can grow many things any time of the year in any weather. So you have a lot of control over your system and the environment. So recycling the water, you can grow in droughts and areas with little water. Less pests because you're growing indoors and you're growing off the ground, so you don't have a lot of pests to deal with. You don't have to weed your garden. Plants grow really, really fast, and they're really, really fragrant. Your herbs and everything that comes out of this, it just smells beautiful. Okay, so you can get income from the fish and the vegetables. Okay, so you don't need the fertile soil, so you can grow in any place with it. So it's good for deserts, it's good anywhere. You can use grow lights if you need. Okay, so the environmental factors, water conservation, less water. With traditional fish farms, sometimes you're running off the water from the fish farm into natural lakes or rivers. So you don't have this runoff. Everything stays in the system, so there's no waste going into the environment. Okay, so being able to grow food from any environment, then you don't have to have your food shipped from other countries or other places, so you're using less petrol to get your food to the consumer. So even with grow lights, there's a lot less energy than commercial farming. Okay, so you don't need a lot of land to grow food. Okay, and of course, you know, it's very, very healthy. Having your own vegetables growing in your backyard is very, very healthy. So hydroponics is nice, but you have to change out your water supply. So where does this water go? It goes onto the land, and then you have built up salts and things in the water. So that's about it for that at the moment. Okay, so why am I doing this project? Well, first of all, I need to learn to code. I need to build things just to get good enough to have a job, so why not build something that I'm passionate about? I'm building up a portfolio, and this is one of the things to show people that I can actually build things. So next, I believe in it. I believe that everybody should have a garden. I believe in food security. I believe in protecting the environment. So this is something that I believe in. So I want to make this an open source project. I want the code and the setup available to everybody. So people who want to build this should be the code and the instructions on how to set it up should be available, because some people like doing this type of stuff. I'd like to keep it protected, so I probably wouldn't mind some sort of intellectual property over this. So I want to simplify these aquaponics gardens so more people can have them. So this should educate people and make it easier for people to understand this process and grow their own vegetables and fish. So if it's commercially viable, which I don't know if it is, then I need far more resources than I have. It's one person building it, and I can only do so much work with a full-time job. So what problems does the app solve? Well, the main problems are you have to do testing all of the time. You have to test for ammonia, keep your water temperature at the right place, make sure there's no water leaks. So there's a lot of research and effort that goes into this system. So you need to know your system, you need to know how it works. If I can make all of that simpler for people, then maybe it's something that people will buy. So every day you have this testing. You have to do your water testing, checking the pH, checking the ammonia. The nitrites and nitrates at this stage are really not something that is going to poison your fish. So if you have your plants are growing healthy, then you can grow more plants. So nitrates and nitrites are not really something that you need to worry about. Okay, so yeah, once I had this tank, I had an aquaponics set up, and I told my housemate, I was away for 5 days, I told my housemate to feed my fish half of what I normally fed them. And I don't know what happened, but when I came back, the fish were almost dead because they had slowed down. They weren't eating so much, and basically the food wasn't being eaten by the fish, so it remained in the system, which caused the ammonia to spike really, really high. And when I got back, my fish were almost dead, which would have been absolutely tragic. So if I could monitor this system from my telephone, I could see the ammonia spiking, then I could have maybe called her and told her, no, just don't feed them anymore. So it's for busy people and people that might leave their system for days and want to monitor it. And then you want to keep information about your system just to make better decisions. For example, if your temperature is in a really high range, you might want to grow different fish next year. So you want to track your information and see what things you can do to make your system better. So how the system works. Okay, so you connect a small computer to the system. I'm using a Raspberry Pi. I think it's a Model B. And this will take the probes. So you have your probes attached to that. And this will send information over the internet, and it'll send information to your phone in real time, and it'll track everything in a database. So it will be a progressive web app. Instead of building two applications, one for iOS and one for Android, it'll be a web app that will install a little bit of information on your telephone, and then it'll be able to give you the notifications live. So I'll have a look at the project. You can have a look yourself, but I think it'll make sense. Okay. So I have some information here. This is for people who are thinking about employing me, just a little bit of information so they can understand what the project's about from an employer's point of view. Okay, so here's the proof of concept. It's just a show of what might be. So what we have here is a substitute for the readings of the probe. So instead of building this application and actually having to use the probes to test it, I have these little sliders that will simulate the changes in the water quality. So we have temperature here, and we have the high temperature, low temperature. We have the pH of the system and the ammonia of the system. So this is what information will be coming from these probes. So when your temperature starts to get up, you can get notifications, and these will come through as a little buzzer on your phone. So you have all of the different ranges. So here you can see, so this will be like monitoring your system in real time. You can have a look on the page, and you can have a look what fish your system has, what the ideal temperature is, what the ideal ammonia is, and then you'll be able to see what your actual ammonia is, and you'll have these alerts where you can see. So if you have a low temperature, then you can have a little bit of a read here. Then this will link you to some information to help you to fix any of these problems that you might have. If your pH is off, then you'll have this information here to show you and how to read about it. So at the moment I'm just collecting information to put in the database. So here you have your historical data. So you'll be able to go back and look at your data. So you have the temperature readings for 24-hour period, 7-day period, 1-month period, 1-year period. And you can track what the temperature was and what the time was when all these readings were taken. So here you can see how much time your system has spent in the optimal temperature range. So 79% is good, and then low warning, so you've got 4% in this. So you can see how good your system's going overall. So this will also be 12-month period, 1-month period, etc., etc. So you'd also like to track your daily highest and lowest temperatures here. Let's zoom in. Highest and lowest temperatures. So there'll be all sorts of data that you can get about your system, and you'll make better decisions on what fish to have in your system and things like that. So then also you'll have these system advice pages. So you'll have all of the information about the fish that you have in your system and other fish that you might want in your system. So you'll have your ideal temperature, your stocking density, descriptions, and how to care for it. So this is just some text to hold the place. So here's managing temperature, and you'll have a step-by-step guide how you can fix any problems with your system. Okay, so that's about it. Okay, so if you want to keep up to date with this project, then I have a web page. The links will be in the description for all of these. So I have my blog here, and it has all of the information that you might want. So different posts about how the project is progressing. So you can sign up to this and get emails, and you can have a look at this. Okay. Okay, so this is maybe the technical information. At the moment, I'm building it with Node, React, Express, MySQL as a progressive web app. Okay, so I have documentation. So on this one, down here you have the architecture of the application, PDF or Draw.io, project requirements, and promotional infographics. So you have GitHub. So I have my code on here. At the moment, this project is on the same page as my portfolio, but maybe a little bit later, once I've gone past the proof of concept and I actually start to build this as an application, then you should be able to find it in my projects. So, okay, so I'll be building this as a project, and I'll be putting all my tasks and everything in here for people to do, to help or to look at. Okay, so what am I doing now? I'm still building the proof of concept. So I'm building the React info pages. I'm researching information for the info pages. Yeah, so back to this. I'm connecting the historical data to the readings that I get from the database. So now I'm connecting up the database, and I'm checking out these data visualization libraries, and basically that's where I'm at. Connecting up the database, building these pages. So what do I need help with? Yeah, there's info pages. I need help, maybe researching and finding out what people might want from this system. So is this actually a good idea? I probably need some help protecting the concept. I don't mind people building this for themselves, but it'd kind of be a shame if somebody with a lot more money and resources than I stole this concept and then started to sell it and then put copyright on it, and then I have no access to it. Yeah, so that's it. That's my project. All the links will be in the description. Thanks for watching.